All right, section 4.5 is simplifying algebraic fractions. We are going to use the concept of greatest common factor to reduce or simplify fractions. This fraction, 10 over 25, can be written in a smaller form that actually it'll be the same fraction, but it's like it's got a nickname. So I find the greatest common factor and divide both the top and the bottom by that number. So the largest number that can go into both 10 and 25 would be 5. So what I'm going to do is I'm going to take 10, I'm going to divide it by 5, and I'm going to take 25 and divide it by 5. It has to be the same number that you're dividing into both of them, and I get 2/5. So the fraction 2/5 is just another name for the fraction 10/25. So I come down here, the largest number, or the greatest common factor for 12 and 30 would be 6. So I'm going to divide the top and the bottom by 6, and it's going to give me 2 over 5. Again, that is going to be another name for 12 over 30. Let me go 6 and 18. Largest common factor is 6, which is going to give you 1 over 3. So 1/3 is another name for 6 over 18. 9 over 27. Let's say we didn't come up with the greatest common factor. Let's say we came up with just 3. And I end up getting 3 over 9, but then I look at 3 and 9 and I go, I can divide both 3 and 9 by the same number as well. So I'll divide it by 3 again until I get a number that I can't divide the same thing into the top and the bottom. So I go until the greatest common factor between the top and the bottom would be 1. Reducing fractions can also be done by prime factorization. If I want to look at this as the prime factorization of this is 3 times 3, the prime factorization of that is 3 times 5. If I have a 3 on the top and a 3 on the bottom, that's the same thing as 1. 3 over 3 is equal to 1. So I mark those out and I get a fraction of 3/5. It's another way, maybe not the easiest way, but it's definitely another way to reduce fractions. On this one, 2 times 2 times 2 times x is your prime factorization. 16x is 2 times 2 times 2 times 2 times x. So those equal 1, those equal 1, those equal to 1, and those equal to 1. So what I have left is an x on the top and a 2 on the bottom. And that would be what I would get when I reduce it down. So let's look at these. I typically do a combination of the two. So I'll do the prime factorization of my letters, but I will look at my numbers and decide what is the greatest common factor between them. So first thing I'm going to do is I'm going to divide the top and the bottom by 7, because that's going to be the greatest common factor number-wise. So that's going to give me a 3, and now I'll do the prime factorization of the numbers. So I have x times x, and on the bottom, I have x times y. Well, x over x is equal to 1, so I'm left with 3x over 5y, which would be the simplest form of that fraction. I'm going to divide the top and the bottom by 6. And that's going to give me 2 x, y, y, y over 3 x, y. X over x is 1, y over y is 1. So I'm left with 2 y squared over 3. Now you try a couple, come back and check them, see if you got them right. Greatest common factor of my numbers is 5. So that's going to give me a 4m times m times m times n times n over 13 m n. So that marks out, and that marks out. So on the top I have 4 m squared, m times m, and an n. And on the bottom what I have left is a 13. I hope you see that those are the ones we have left. Okay, on this one, greatest common factor, let's see. I'm thinking, let's see. Let's try it with just, I know that 8 will go into both of them, so we might have to reduce it and reduce it again. Or you could do a factor tree and find the greatest common factor. So that's going to give me 9 over 15. But if you look at 9 and 15, I can divide the top and the bottom by 3 here. So I've got to keep going till I get 3 over 5. So that would have been, the best way to do it would have been dividing them by 24. So 24 is the greatest common factor between 72 and 120. But you can do it by dividing it a couple times too. All right, your homework on this is page 172, 14 through 40 even.